Hello, my name is Yoav Caspi. I'm a senior lecturer at Kingston University and the Architectural Association School of Architecture. And I'm excited to present this keynote presentation to the Elsewise Academy. I'll now share my screen to provide more information about this presentation and share more information about myself. This keynote presentation is called Extended Touch CNC Fabrication. In this keynote presentation, I'll introduce CNC fabrication and present two case studies where CNC is used in construction and architectural practice. After, I will discuss CNC in the fine art and explain how I use CNC in my design practice as a tool of sculpting. My name is Yoav Caspi. I am an architect and the founder of Yoka Design, a sculpting studio specializing in reliefs and lamps. I recently exhibited in the Beyond Blueprints exhibition as part of the London Design Festival with Gubbins Gallery, a gallery that represents me. I am a senior lecturer at the Architectural Association School of Architecture and Kingston School of Art. At Kingston, I work with Kingston Council and students to bring disused buildings back to life. I also teach master students how to use CNC fabrication as a sculpting tool, making reliefs. I previously led a master studio at London South Bank University, which focused on sustainable energy use. Before teaching, I worked at several renowned practices, including Ron Arad, Tonkin Liu, and Alfred Hall Mahanigan Morris. I also worked at David Corn Architects, where I designed the Waddington Cousteau exhibition, which showcased works of female sculptors from the 1950s and 1960s. At David Corn Architects, I also worked on New College, a new campus situated in the center of Oxford, as well as the shortlist entry to the National Gallery, specifically the Sainsbury Wing, a Grade 1 listed building that was initially designed by Robert Venturi. With all my projects, I study the past and celebrate the future through contemporary design. And this is where CNC comes in. I believe that advanced fabrication techniques, such as CNC, can facilitate this synergy between the past and the future. It allows designers and architects and artists to achieve ambitious designs with reduced cost and labor. CNC stands for Computer Numerical Control. It is a broad term used to describe a process of sending digital information to a mechanical tool that then automates and carries out a task you set for it. Most often, this digital information translates to a milling process where material is removed from a foam block, a piece of metal, or a piece of wood. CNC is used in many industries, such as the automotive industry, the furniture industry, and in architectural practice, it is often used as a tool of architectural representation to make site models, molds, and reliefs. Later on in this presentation, I will also discuss how CNC can be used in fine art as a tool of sculpting. This is an example of a site model that was made using laser cutting and CNC fabrication. You can see the difference with the levels between each height within this landscape. On the right, the CNC model shows a much more smooth and fine resolution of the site model. In the last decade, the use of advanced fabrication techniques such as CNC is growing in the construction industry, architectural practice, and in fine art. CNC is used to fabricate architectural elements and large-scale construction components. As highlighted, CNC is a fabrication process where materials are removed to achieve the desired result. This is called a subtractive manufacturing process. In comparison, 3D printing is an additive manufacturing process. This is an important distinction to make as there are advantages and disadvantages associated with each manufacturing process. The most evident disadvantage of subtractive manufacturing process is material loss. When you subtract material, when you mill wood or foam, the material being milled becomes dust. This dust often ends up in landfills. It is waste. Considering the effects of embodied carbon and waste on climate crisis in our world, we need to make sure that we are aware of this waste while we're designing our objects. Another interesting disadvantage that you might want to pay attention to is the scale of the CNC machine. You can't mill very big pieces. Often those are constricted to a size of 2.5 meters by 1 to 5 meters. The slide before us is restricted to a CNC bed that measures 50 centimeters by 40 centimeters. I want to share now two projects I worked on that demonstrate how CNC can be used in architectural practice and fine art. The first project is a construction system named Block. I worked on this project with Auer and Yip using this construction system to build two pavilions in Clapton and Bristol. Block is a construction system that uses identical plywood blocks to build structures and house extensions. It is designed to facilitate assembly, making construction quicker by using identical plywood blocks that can stack easily. This approach of using identical architectural elements and construction components is often referred to as modular architecture. The premise of this project suggests a future that democratizes building system by allowing the local community to take part in the construction process. I'm now going to read a quote by Auer that describes this in further information. In further detail, I should say. Hausblock asks us to dare to think of a future that democratizes access to building systems. One that elevates the housing crisis and support labor practices threatened by ever-increasing automation. So there are interesting ambitions here. One is to give more ownership and power to the people and the local community. And the second one is to, by giving more power, by giving more ownership, is to potentially elevate the housing prices. So to build more by making labor more quicker and accessible. Now I'm going to describe Block in more detail, technically wise. So each plywood block is made out of 12 panels that are milled in CNC machines. In addition to the panels, there is a secondary internal structure of cables. The cable reinforces the structural properties of these blocks, allowing them to perform well in tension. Finally, the blocks are connected using bolts. Block was originally constructed in Bristol. Some of the blocks from Bristol were then reused in Clapton, London. Reusing blocks limited waste throughout this project. Beyond its technicalities, this project is social at its core, aiming to give ownership and knowledge to the local community. The first pavilion, Block Bristol, was nominated by AJ and Arc Daily for the Best Small Project in 2020. Another example where CNC was used as a manufacturing technique is the Sunrain Rooms. The Sunrain Rooms is an extension of the home and office of Tonkin Lu. In this project, CNC was used to fabricate the wood for the experimental timber roof. I oversaw the fabrication of plywood for this project using a CNC machine in Lacey Green in the United Kingdom. The roof is constructed from more than 50 Malaysian plywoods and 200 coffers. It takes its shape from a wooden formwork that was placed below the roof to give it its form. The wooden formwork was also fabricated using CNC machines. The sheets, sorry, are layered one after the other while placing more smaller sheets that we called coffers to create this performed ceiling pattern. You can see this in more detail in this image on the right here. These are the coffers that are stacked one on top of one another, and these are the roof lights, the holes in the coffers that stagger throughout this roof construction. In this detail, you can see how the sheets of plywood are layered on top of each other. In some way, this is like laser cutting on a much larger scale. The Sunrain roof is often accessible to visit through Open House, which is an open event, open festival in London that invites people to explore architectural gems throughout the city. So if you happen to be in London next year around September, you might you might be able to get access to this building. These two case studies demonstrate the potential of CNC fabrication in construction. While Block showcases how CNC can be used in modular architecture, the Sunrain roof shows how it can be used as a bespoke application. In my practice, I use CNC as a sculpting tool, making reliefs. Reliefs are sculptures with a flat surface. They are artwork used to decorate interior or external spaces. The themes of my work focus on scale, identity, and form. This relief, called Mask 1, explored the tension between masks as vehicles to celebrate or conceal identity. The geometric pattern echoes my architectural background. The process of making relief usually involves three stages: designing, CNCing a mold, and casting. I'm now going to talk about each step, in further detail. In the design process, I start by researching a conceptual design approach. I sketch a design, drawing sections and plan to achieve further detail. In sections, I particularly focus on the level between each surface, and in plan, I focus on the composition of my artwork. After I draw sections and plans, I translate the drawings to a three-dimensional object. You can see an example on the right. After I translate my drawings to a 3D object, I CNC my mold. And again, you can see an example on the right side. This involves a series of stages, such as preparing toolpaths according to my design using dedicated software. When I say CNC toolpaths, I mean a script that tells the CNC machine where to move in order to remove a specific amount of material. So that would be telling the CNC machine to move 20 millimeters to the x-axis and 50 millimeters in the y-axis and 10 millimeters in the z-axis to achieve a specific design. This often works all at once in a very quick process, and this is really one of the advantages of the CNC machine. After I prepare the CNC toolpaths, which is prepared using dedicated software, I start preparing the material on the CNC machine itself. So I start by securing the material to the CNC bed. I install the Corel drill bits according to the toolpaths that I prepared. There's a variety of drill bits, and each one of them are appropriate for a specific design. Drill bits are often differentiated by their size, by how many flutes they have, and by their end finish. If you want to achieve a very smooth finish, you'd usually use a bow nose drill bit. And if you want to use a more of a cut, a straight finish, you'd use a flat bit, we call it. After I install the drill bits, I also set the correct origins according to my piece and my design. It is very important to set the origins to the correct place so the design that we've prepared in the software that we use corresponds with the design with the material that we've placed in the CNC bed. After we secure the material to the CNC bed, we install the drill bits according to the tool path and we set the correct origins according to our piece and drill bit. We mill the design. In the last stage of how I make a relief, I cast the plaster into the mold. This again involves a series of stages. I prepare my mold so that it can be the foam itself, so the piece that I've prepared in the CNC machine. If I pour plaster directly into that mold can't be reused. Another option is to make a vacuum form of that mold. A vacuum form is a plastic sheet that comes on top of the yellow foam mold and borrows its geometry. This plastic sheet can be used again and again. And it also has a very smooth finish. I often also apply some a material that kind of differentiates between the plaster and the material that I pour the plaster on. So if it's yellow foam, I would spread some Vaseline on the yellow foam so it would be easier to release the plaster. And if I use plastic sheet, I would probably use Vaseline as well. I pour plaster into my mold. I wait for it to dry, and then once it is dry, I release it. I send the final piece, and then I apply any additional coatings as necessary. Um, these are example of two reliefs that I'm currently working on that are part of the mask series, which delves into the complex symbolisms of masks as vehicles of identity. In these series, I investigate how masks have a capacity to celebrate the cultural heritage and also as a role as shields behind which identities are hidden. Other reliefs that I make are inspired by my architectural background. Flowing Center, for example, composes one journey through an abstract landscape. It is a study of Noguchi's visionary design for the contoured playground. In this design, Noguchi wanted to create a space where children can play and dream freely by protecting them with curved surfaces from every angle and direction. I want to read this quote by Noguchi that describes this in further detail. I felt obliged to answer all the dire warnings of the danger to which I would expose small children with my play equipment, and so designed a contoured playground. This would be proof against any serious accidents being made up entirely of earth modulations. The exercise were to be delivered automatically in running up down the curved surfaces. There was various interest for hiding, for sliding, for games, and water would flow in the summer. Noguchi was a visionary landscape architect, artist, and designer who dwelled in America with Japanese origins. I want to share some further work I have developed over the years with my students, both in Kingston School of Art and the Architectural Association. Joshua Godley, for example, prepared a series of interlocking blocks as a bespoke column that is situated within the gallery that he designed. Manar and Joe both created tiles, reliefs that could be positioned on the facade of their buildings. Oscar and the Architectural Association prepared a series of tiles and imagined how these could occupy a wall within an exhibition. Dongin Lee was inspired by primary shapes such as arches and squares and rotate them to achieve a dynamic interplay between light and shadow. Beatrix Stork developed a series of reliefs that aimed to freeze fabric in space. She was particularly interested by a relief artwork by Enrico Castellani called The White Surface. Similarly, with my work, I often work with tiles. This is the dancing balconies that envision a set of balconies and architectural elements that kind of play with one another and show, again, a dynamic interplay of light and shadow. To conclude, CNC fabrication is a subtractive manufacturing process. It is growing in popularity in the fine art, architecture, and construction industry. This technique provides freedom and capacity to achieve intricate designs while reducing costs with limited labor. I want to give my thanks to Kingston University, to the Architectural Association, and to Auer and Yip for working on Block, and Tongking Lu for participating in the Sunrain rooms. Thank you for watching this keynote presentation.